Okay, so we're going to continue what we did yesterday, graphing inequalities. So this first one is ready for us because the y is alone. So I can go right to my calculator, y equals. So x plus 4. Okay, I'm going to get some points. So I'm going to go trace. So 0, 4. Okay, and I can see that already from my equation up there. So there's a point, and I'm going to go 1, 5. So there's 2 points. Okay, it's just going uphill one at a time. Now, when I draw this line, I'm going to give you 2 options. Should we draw it as a solid line or a dashed line? Looking at this symbol. What does that mean? I'm going to go dashed. Okay, we cannot be equal to the line. We have to be less than this line, so we're going to dash that. Okay, which side am I going to be on? So I'm going to give you 2 choices here. So the red side or the blue side? Which side is showing me this symbol which says less than? So it's going to be the blue side, right? Okay. It says I need to figure out 3 points that are solutions. And then 3 points that are not solutions. So we're going to list 3 points that would work and 3 points that are not going to work. Okay, can you name me a point? Basically anywhere that you've shaded. You got a bunch of them. So I could go here, which is a coordinate 10, 0. Oh, I could do the origin is in that zone. So 0, 0. I could do anything like in this zone. For instance, I don't know, 4, -5 would be in this quadrant, and that would work. Okay, solutions, those are them. Now, what is not a solution? So I could pick, I'm going to do this in pink, I don't know if you can see it. Not a solution. So for instance, a point over here would not be a solution. So I'm going to go -10, 0. Any point kind of in this zone would not be a solution. So I'm just going to make something up kind of in this region. So -4, 9 would be somewhere in that location. -4, 9. You can make a bunch of them up. Here's another question for you. What about this coordinate? What do you think about 0, 4? Would it work or not? No. Because it's right on that line, and we can't include that line. That's good to know that that is not a solution. Okay, next one, B. Before I put this into my calculator, I got to do some algebra. So remember, our calculator has to have y, and we don't have y. We got some other stuff. So how do I get y alone? What operation is going on right now? It's being times by -1. So I'm going to divide by -1. Do you remember that crazy thing it did? It does something when you divide by negatives. The sign is going to flip. So now this is what I can put into my calculator. Okay, once I have y alone, that's what I can do. If you did not like this algebra step, you could have just taken your original. You could do this as well. If you don't like physically doing that, you can let your calculator do it for you. Okay, so show me what that will look like with your calculator. So 0, -3 is a point, and I need any other point, so 1, 3. I just hit 1, enter, and it shows me another point. Solid or dashed, those are our options. So we are not equal to this line. And which side of the line are we going to have to be on? So there's my two options, and this says greater than, this symbol. Greater than, so which direction is going upward? The red side or the blue side? That direction is going angling upward, barely, but it is. Okay, so here would be points that are solutions. Can you name me 3 points in that zone? So something like that, -4, 0. I don't know, 0, 8. I don't know, you can pick your own, but anything in that region are solutions. Just make sure you're naming your points. Okay, what is not a solution? So anything on this side is not a solution. So for instance, 10, 0, not a solution. 5, 5 would not be a solution. Okay, a few options there you can pick. Okay, next. without graphing, determine if the point is a solution or not. Okay, so this is me going to plug in, and I'm going to do some algebra. So do we remember points always are x and y, right? Points are always the x and then the y. So I'm going to plug this in. Ready? 2 times, replace the x with 1, plus 3 times, replace the y with a 1, is greater than 5. Two plus 3 is greater than 5. What do you think about that? Is that right or not right? Is 5 greater than 5? No. So nope, that's not going to work. If I had changed that symbol to have a greater than or equal to, it would work. Okay, x, y, make the replacements. So 2 times 1 plus 3 times 0. So this makes 2 plus 0 greater than 5. Is 2 greater than 5? Is that accurate? Nope. That's not a solution. Okay, last. So 2 times, replace x with a 1, plus 3, replace with a 2. So this makes 2 plus 6. Is 8 greater than 5? So that one is a solution. Okay? So you can figure all these coordinates out, the ones we did before. You can also plug those in, right, into the equation and see if it makes it true. Okay, so this last question says, explain why this point is not a solution, even though I plugged it in, and 17 is greater than 10. That was true, but why is this coordinate not a solution? Why is this coordinate not going to work for this example? Anybody see why it's not going to work? Has something to do with this part of the question. Do you remember what that says? It says x has to be a whole number and your y has to be a whole number. What do whole numbers mean? Remember that one? They're 0 and up. So the reason it can't be a solution is that I can't include it if y is -2. Because it told me that x and y had to be whole numbers.